Welcome to this first video. In this first video, we're going to be learning how to convert from rectangular form into polar form. There are two important words that you need to look out for in this video. One is modulus and one is argument. So let's get started. In question 1, we're asked to find the modulus of 3 plus 4i. I'm going to start by putting this on an Argand diagram for you with the real axis here and the imaginary axis here. So if you remember, our number was 3 add 4i. That means we're going to go along the real axis by 3 and up by 4 on the imaginary axis. So this number would appear here on the coordinate axis system. The first important skill is that you're going to join up the origin to the point that you've marked in the Argand diagram, and you're going to form a right angled triangle like this. Okay? I'm going to just gently shade that in for you. And here's the right angle. You can think of the modulus of a complex number as the distance from the origin to that number on the Argand diagram. Or you can think about it as the hypotenuse on this right angled triangle. Now remember, we had 3 on the real axis and 4 in the imaginary axis. To find the modulus of this complex number, you're going to use a skill which is really familiar to you, which is how to find the hypotenuse of a right angled triangle. And we do this using De Moivre's theorem. The notation that we've seen before in the modulus series is 2 vertical bars. Okay? And then we're going to calculate that by using Pythagoras' theorem and saying 3 squared plus 4 squared. That would be the square root of 25, and that would be 5. So the modulus of 3 plus 4i is 5. Okay? Now the next key word that you need to learn in this video is how to find the argument of a complex number. We're going to repeat the steps that we learned in the previous example and start by plotting this on the Argand diagram. So this is pretty small, so I'm going to go along here by 1 on the real axis, okay, because I've got 1 here, and up by 1 here. So my complex number is going to be marked here, and I'm going to join it up to the origin and going straight down and straight across. Now let's zoom in a little bit here. Now, we define the argument as the angle made with the real axis. So a flashback here to everything you learned about the unit circle, okay, and the 4 different regions, we form the angles like this. In region 1, we take this angle. In region 2, here, 3, and 4. And the nice way to remember that was to think about that like a butterfly. So in region 1, I need to calculate this angle here. Now the complex number I started with, which was in rectangular form, was 1 plus I. Rectangular form means that the number is in the form of a plus bi, okay, where a and b are real numbers. So you have usually a real part and an imaginary part. So in this case here, I have 1 on the real axis and 1 on the imaginary axis. And in order to calculate the argument, I'm going to use arctan, and that's because I know the opposite here and I know the adjacent here, and it's a right angle triangle. So the 2 ratios I have, so the correct ratio to use that connects opposite and adjacent is tan. So I'm going to do the argument of, I think this was called Z2. The argument of Z2 is going to be equal to the angle, which I'm going to calculate using arctan of 1 divided by 1. So that's going to be arctan of 1 divided by 1 is 1. Arctan of 1 is pi over 4 in radians, or 45 degrees. So now you have already learned two important skills. They are how to find the modulus of a complex number and how to find the argument of a complex number. And we can kind of summarize that if our complex number is x plus iy, okay, like this, the modulus of z would be equal to the square root of x squared plus y squared, okay, which would be this distance here. And the argument of z would be equal to arctan of the opposite divided by the adjacent. So that's getting us off to a really good start. Now we're going to go one step further and we're going to express something in polar form. The difference between polar form and rectangular form are two different ways of expressing the same complex number. For example, if I have a length, I can measure it in centimeters or inches. They're equivalent measures, but they're different ways to measure. So we said already that the rectangular form is in the form a plus bi. So something like 5 minus 3i, that would be in the rectangular form. Whereas something in the polar form, we're going to express it like this. r cos theta add I sine theta. Now that seems a little bit complicated right now, but stick with me and I'm going to explain how you're going to achieve that. I'm going to teach you how to put something in polar form with an example. I think it's the easiest way to see it. So we're going to start by imagining that we had an Argand diagram, and just like the previous two examples, we drew a right angled triangle. This is in region 1 because square root 3 is positive and 1 is positive. You think that's 1i. Now, see if you remember how to find the modulus of that complex number. Square root 3 squared plus 1 squared to do our Pythagoras theorem, which gave us 3 plus 1, which gave us 4. And the square root of 4 is 2. Okay. Then, once we've calculated the modulus, we're going to find the argument here. Arctan of opposite, which is 1, divided by square root 3. Do you guys remember that one? That is an exact value. That is pi divided by 6, or 30 degrees. So now, remember, we want to change from being written in the form of x plus iy, which in this case is 1 plus square root of 3i, to be using the modulus and the argument. So what we do is as follows. You can think here was the x and here was the y, and this is the radius or the modulus is this length here. Now we know what theta is. In our case, theta is 30 degrees. So if we start by thinking, how could we get an expression for x? Well, x is going to be the adjacent of theta, and y is going to be the opposite of theta. And bear in mind, we definitely know what r is. So in this case, we could say x is equal to, or x divided by r is equal to cos theta. That's adjacent divided by hypotenuse. If I times by r, I know that x is equal to r cos theta. I can repeat that for y. So I know here that y divided by r, that's opposite divided by hyp, must be equal to sine theta. I can times across by r, and y must be equal to r sine theta. So if I took my original expression, which was x plus iy, then that must be equal to r cos theta add I, which was here, and then y must be r sine theta. And now I can take out here the r and get cos theta add I sine theta. Let's put that theory into practice with our example here. we know that cos pi over 6, okay, must be equal to adjacent over hypotenuse. Okay, so therefore square root 3 must be equal to 2 cos pi over 6. And to find out an expression for 1 in terms of the modulus and the angle, I can say the sine of pi over 6 must be opposite divided by adjacent, must be opposite divided by hypotenuse. I can times by 2, and that will give me 1. Therefore, if z is equal to square root of 3 plus I, it's also equal to 2 cos pi over 6 plus, remember this is 1i, I times by 2 sine pi over 6. And I can factor out the 2 here. And then we write that in an abbreviated form like this. You write 2 kiss, and you just put the angle in here. One quick one that I'm going to add on to the end is if you have a number like, for example, 5 that you want to write in polar form or in kiss form, all you have to do is think that 5 would be here. So its angle, if we measure it in the same way we measured it on the unit circle, its angle would actually be 0. So how far away is it from the origin? Its radius would be 5. So we could write this as 5 kiss 0. If I had, for example, 2i, I would say that its angle would be, that would be pi over 2, measuring in an anti-clockwise direction from the real axis, and it would be a distance of 2 away from the origin. So I could say that that's 2 kiss pi over 2. So that concludes our first video, a little bit longer than I was expecting, on how to convert a number that's in rectangular form into polar form. And polar form is super cool because you can visualize this whole new coordinate system, whereas instead of always counting in squares, we can count in circles. So 2 kiss pi over 6, we can look at that on a polar coordinate, and it would look like this. Well, pi over 6 is going to be 30 degrees, and it's going to have a radius of 2. So this, all of this circle here has got a radius of 2, but this is the only one that's got a measure of 30 degrees. So you can open up a whole new way of drawing things on grids, which uses concentric rings instead of squares. So I think that's pretty cool. In the next video, we're going to go into what's the difference between argument and principal argument form. There's a little technical definition that I'm going to explain to you guys. I will see you in the next video. Bye for now, guys.